Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to find the powers and roots of complex numbers in polar form. This standard is covered in pre-calculus. Don't forget there's a two-part practice problem at the end of this presentation that we'd like you to try out in order for you to demonstrate your mastery of the content covered. Links to the playlist and the entire course can be found in the links in the description below. And if there is anything that we didn't have covered in this presentation, just feel free to include it in the comments section. All right, the example that we're working on is as follows. So let's say we have a complex number. So let's call it z, okay? So if we have a complex number z given by 8 cosine pi over 2 plus I sine pi over 2. Now this is a task. We're to find, first of all, we have to find the complex number raised to the second power. And then B, we have to find the third root of the complex number. Okay, so for this particular problem, in the B part, all we're looking for is just the principal root. There are two other roots, but we're not going to be looking for them in this particular presentation, okay? All right, let's start with the first part, part A. In part A, we're to find z raised to the second power. Okay, what is this complex number in polar form squared? Now, in order to do that, let's get started by writing down the formula that will guide our problem solving process. And the formula is as follows. So if you have a complex number z raised to the nth power, what you have is the complex number in polar form r cosine theta plus I sine theta. You have that complex number being raised to the nth power also. Okay? All right, so how do we calculate the power? Well, this is how it works. What you're going to do is you're going to raise the radius to the nth power, and then you distribute this power to the respective angles, okay? So it's going to be r to the n times cosine n theta plus I sine n theta. All right? So that's basically the formula for finding the power of complex numbers in polar form. Okay, so from the setup that we have up here, we can easily determine what r and theta are. Okay, so from this setup, we have r is equal to 8 and theta is pi over 2. Alrighty, how do we know that? Because if a polar number is written in, if a complex number is written in polar form, it's going to be r, and then cosine, the angle of the trig function, is the theta, and the same applies to both the sine and the cosine thetas. All right, so there goes r. R is the constant outside, which is 8, or the coefficient of sine and cosine. Okay, all right, so there you have it. So we're going to plug it into these two values into this formula right here and compute the second power of our complex number in polar form. Okay. All right, so we have z to the second power is going to be 8 cosine pi over 2 plus I sine pi over 2 raised to the second power. Okay, so if we apply this formula that we have here, that's going to result in 8 raised to the second power times cosine, the angle, the power, which is 2 times the angle, so 2 times pi over 2, right, plus I sine, the same process, 2 times pi over 2. Alrighty, so that's how it is. Let's go ahead and simplify our answer. We're going to have 8 raised to the second power is 64. 64 cosine. So the pi over 2's divide out. So we have 64 cosine pi plus I sine pi. All right, so this is the z raised to the second power in polar form. Okay, so I also like you to write down what the answer is in rectangular form too. Alrighty, so this is polar form. Let's go ahead and convert this to rectangular form. So without a unit circle, we're going to need to, without a calculator, we're going to be making use of a unit circle to figure out what cosine pi and sine pi are. Okay, or you can just use the sine curve to figure it out. It's the same process. But we're going to be using the unit circle here. So there goes my x axis and my y axis. All we need is just the first quadrant of the unit circle. Actually, we're going all the way to pi, so we need more than that. So let's make this a little bit bigger. So we need half a circle to make this work. Okay, so we have our half circle right there, portion of our unit circle. Now, what do we need? We just need to identify where pi is on our unit circle. So this is 0, and this is pi over 2. Pi is equivalent to 180 degrees, okay? So this quadrant right here, this coordinate is 1, 0. Pi over 2 is 0, 1. Remember, the radius of the unit circle is 1 unit long, okay? And then this over here is -1, 0. So we know from our unit circle that the x coordinate is cosine and y sin, right? The y coordinate is sine. So from this unit circle, we can easily see that cosine pi is going to be -1 and sine pi is going to be 0. All right, so let's go ahead and put that in. We're going to be expressing this complex number in polar form in rectangular form now. So we're going to have 64 times cosine pi is -1 plus I sine pi is 0, as you can see from the unit circle. Okay, now if we simplify that, we have 64 times -1 plus I times 0 is just 0. And then 64 times -1 is -64. All right, so that is the answer to the question in rectangular form. Okay. All right, now let's advance to the B part. So for the B part, we're going to be looking for the third root of z. All right, so for the B part, we're looking for, so we want to find z to the third. I'm sorry, we're looking for the third root of z. Let's write that down. So the third root of z. Okay, so let's go ahead and write down the formula that's going to guide our problem solving process for computing the roots of complex numbers in polar form. Okay, all right, so it's very similar to this power right here. So if you're looking for the nth root of z, you just have to write it as a power. Okay, using the nth root property of exponents, you can rewrite this radical as z to the 1 over n, like that. Okay, and then just follow the same process that we have here. So this is going to become the nth root of r, so r to the 1 over n. You notice in this formula here the power was n, so let's do this. Let's apply the formula to the complex number in polar form first, so you can clearly see how they're similar. So let's say we have the complex number r cosine theta plus I sine theta. Okay, and we want to find the nth root. Okay, so we're raising it to the 1 over n. So it's going to become r, you raise r to the power, which is the root 1 over n because it's a reciprocal. And then what do you think we're going to do next? We're going to distribute that power to the angles. Okay, So that's going to become cosine. So here was n times theta, but here it will be theta times 1 over n, which will result in theta divided by n. All right, plus I sine theta divided by n. Okay, so that's basically the formula that we're going to be using. And remember, what we're looking for here for this particular problem is just the principal roots. There are other roots present, but we're just looking for the principal root in this presentation. Okay, all right. If you want to see how the other roots are done, we have some explanations in other videos. You look at the link in the description, you see access to a tutorial showing you how to find the other roots. Okay, so let's go ahead and apply this particular formula to this problem. So the third root of z is going to be equivalent to z to the 1/3 power. Okay, so what we're doing is we have this complex number in polar form 8 cosine pi over 2 plus I sine pi over 2. What we're doing is we're taking this complex number in polar form and we're looking for the third root, which is equivalent to taking it and raising it to the what? To the 1/3 power. Okay? So if we apply this formula here, we're going to have 8 raised to the 1/3 power. Alrighty? 8 raised to the 1/3 power times, let's draw that again, times cosine. We had cosine of pi over 2, right? So it's now going to be cosine of pi over 2 times 1/3. Okay? Multiplying by the reciprocal is the same thing as dividing by the number. Okay? So if we divide pi over 2 by 3, it's the same thing as multiplying by the reciprocal. So it's the same thing, alrighty? So you have that plus I sine the same thing. Pi over 2 times 1/3. Okay? Okay, so let's simplify that. If we simplify that, we're going to have 8 to the 1/3. It's just a cube root of 8. And you know that 8 is 2 to the 3rd, right? So when you raise it to the 1/3 power, it's just the same thing as raising 2 to the 3rd to the 1/3 power. Exponents cancel out, and your final answer is just 2. Okay, so 8 to the 1/3 is 2, so we have 2 cosine pi over 2 times 1/3 is pi over 6 plus I sine the same thing, pi over 6. And ladies and gentlemen, this is our complex number in polar form. Okay? All right. So what we're going to do now is express the same result in rectangular form. So to do that, we're going to be making use of our unit circle. Okay, because we're not, you can use a calculator, but we're not using a calculator here. We're just using a unit circle. So what is it going to be? It's going to be 2. Now we need to figure out what cosine pi over 6 and sine pi over 6 are in our unit circle. So if we look at quadrant 1, we know that there are 3 points in each quadrant for the unit circle. Okay, we have the pi over 6 or 30-degree point. We have the 45 degrees or pi over 4 point, and we have the pi over 3 or 60-degree point. We're looking for pi over 6 or 30 degrees, which is this one right here. Okay, so for that particular one, for pi over 6, do you remember what the coordinates are for pi over 6, quadrant 1 on the unit circle? So you need to remember your sequence of numbers. So you have 0, 1/2 for 30, root 2 over 2 for 45 degree, root 3 over 2 for 60 degree, and then 1 for 90 degrees. All right, so those are the sequence of numbers that repeat themselves in the unit circle. The signs just differ for the respective quadrants. Okay, so what we're looking for here is the pi over 6 or 30-degree point, which is this one right here. All right, so Let's go ahead and set that up. If we follow the order of numbers here, before 1, so before 1 we have roots 3 over 2. Alright, that's a sequence. So if you're going from 1 down, you have 1 roots 3 over 2, root 2 over 2, 1/2, and all the way to 0 for the x coordinate. For the y coordinate, after 0, going in this direction, what do you have next? Is 1/2, right? So it's root 3 over 2, comma 1/2. That's for 30 degrees, okay? If you wanted to do 45 degrees, it's just going to be root 2 over 2, comma root 2 over 2. And then for 60 degrees is going to be, you see the point we got for 30 degrees, or pi over 6, we just switch it around. Okay, so you have 1/2 and root 3 over 2. And then you see the sequence of numbers we talked about up here, your coordinate values continuum. You have 0, 1/2, root 2 over 2, root 3 over 2, 1 for the x. Switch over to the y, 0, 1/2, root 2 over 2, root 3 over 2, 1. Alrighty, looking nice. So now what we care about in this particular one is just the pi over 6 point, right? So that's what we're going to be using. So I just need to extract the x and y coordinates from there. So the x coordinate is your, the y coordinate is your sine, y sin, don't forget. If you can be good, y sin, right? And then pi over 3 is your cosine coordinate. Bam. All right, so now we have everything that we need. So based on this point that we have here from a unit circle, we can clearly see that cosine pi over 6 is root 3 over 2 plus sine pi over 6 is 1/2 I. Okay? All right, so now we're going to go ahead and distribute the 2 to both numbers here. So distribute the 2, the radius, in. And that's going to yield root 3, 2 root 3 over 2 plus 2 over 2i. And then when you simplify that, just divide out the 2's, you have root 3 plus 2i. Ladies and gentlemen, that is our result in rectangular form. That is the third root of z, or z raised to the 1/3 power. Okay, so that's basically how you find the powers and roots of complex numbers in polar form. So if you have any questions about what we just went over, just feel free to indicate it in the comment section below, and we'll be more than glad to assist. Now it's your turn to attempt these two-part practice problems to demonstrate your mastery of what we just went over in this presentation. All right, so these are the problems we'd like you to try. If we have the complex number z given by 16 cosine pi plus I sine pi, this is the task. You're to find a, the second power, z square, and then b, you're to find z raised to the 1/4, the fourth root of z. And then for the b part, you're just looking for the principal root. All right. Now go ahead and pause this video presentation at this time. I would like you to try out this problem. When you're done, click back on the play button so that we can show you what the answers are. Welcome back. Hopefully you had the time to try out these practice problems. Now let's take a look at what the solutions to these problems are. So for the A part, z squared is equal to 256 cosine 2 pi plus I sine 2 pi in polar form. And then in rectangular form, this is just 256. Okay. All right. For the B part, the fourth root, you can write it as a fourth root of z, which is the same thing as z to the 1/4, is what? It is 2 cosine pi over 2 plus I sine pi over 2. Oh, wait, I wrote pi over 6. I sine pi over 2. Or, well, this is the polar form. Or oh, sorry, it's pi over 4. So 2 cosine pi over 4 plus I sine pi over 4 for polar form. And then when we convert it to rectangular form, we have root 2 plus root 2i. Okay, so that's polar form. So this is basically the power and the root of the complex number in polar form. So how well did you do on the practice problems? Let us know in the comment section below if you have any questions or clarifications that you would like us to address. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of complex numbers and their operations, do give us a like or a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other math tutorials. We upload videos to our math YouTube page on a regular basis, so just subscribe so you can get notification of future uploads. As indicated earlier, if you have any questions or comments or requests for math tutorials, just place it in the comment section below and we'll do our best to respond. More support can be found at mathgotserved.com, or you can just take a look in the link in the description below to gain access to the wide variety of tools that we have to support you. Thanks again for watching and have a wonderful day. Goodbye.